Hello everybody, I hope you're doing well. Welcome back to another video in our Introductory Calculus playlist. So in the previous video, we have gone through some applications of these three special limits that we have derived in the earlier two videos. So we've proven that the limit as x approaches 0 of sine x over x equals 1, the limit as x approaches 0 of cosine of x minus 1 over x equals 0, and the limit as x approaches infinity of the quantity 1 plus 1 over x raised to the x approaches e. And we have gone through some examples where we were applying these three special limits to solve various problems. And we've came across the fact that variable substitution is a valuable technique to make these problems much more doable. So just like last time, on the bottom of the screen right here, you will see a link to the practice problems. And if you click on the link, you'll see a PDF copy. And I'd highly recommend you to follow along with that and definitely solve the problems on your own before you resume the video to see how I solved them. And as usual, don't forget to like and subscribe. Every like and subscribe will make me really happy and make my day. So with that being said, let's continue where we left off. So the next problem we were going to solve was this problem right here. The limit as x approaches 0 of tangent 6x over x plus x over sine of 6x. So the strategy we've seen with sums is break up the limit into the individual pieces using the sum rule. And you will recall that in the previous video, we've seen a limit of this form with the tangent of something over an x in the denominator. This limit was going to go to 6. And then we've also seen this form of, a variable multiplier of x over sine of a multiple of x. This is going to be 1 over 6. So 6 plus 1 over 6 is going to equal to 37 over 6. Okay, so that takes care of that problem. This is just simple application of patterns we saw in the previous video. So the next problem we were going to solve is the limit as x approaches 0 of 1 minus cosine of 5x over x plus 1 minus cosine of 3x over x. Okay, so to solve this limit, we again use the sum rule and break up the limit into its constituent portions. So namely, this will be equal to the limit as x approaches 0 of 1 minus cosine of 5x over x plus limit as x approaches 0 of 1 minus cosine of 3x over x. And now we have to see for this first limit here, right, which special limit from up here, right, matches to what we want to solve. And if you look at the three special limits we have proven in the previous two videos, this limit right here clearly matches the form we're going for, right? Because you're having a cosine of x minus a 1 over an x. So you're having that form, so we want to take advantage of that. So just for reference, let me jot down that special limit so that I don't have to keep scrolling up a bunch of times. So for reference, we know that the limit as x approaches 0 of cosine of x minus 1 over x equals 0. So here we have a 1 minus cosine of 5x over x. But we want to have a cosine of x minus 1. So we're going to pull a negative right here. We're going to pull out the negative. So this is going to be limit as x approaches 0 of negative of cosine of 5x minus 1 over x. Now we're very close, right? Because if you look at this form right here, right, we have a cosine of x minus 1 over x. So this x matches up with this x right here. So you want to have something similar right here, right? So that we can apply this definition with the variable substitution technique. So we have a 5x here, right? But we also want a 5x down in the denominator so that we can perform the substitution, right? And the way we can do that is we can multiply the top and bottom by 5. So I'm going to do that in a different color. So we're going to multiply the top and bottom by 5. Now this is going to be limit as x approaches 0 of negative 5 times cosine of 5x minus 1 over 5x. And then if we let u equal to 5x, what do we get? We're going to get limit as x approaches 0 of negative 5 cosine of u minus 1 over u. This negative 5 is a constant multiplier, but that doesn't really matter because the limit as x approaches 0 of cosine of u minus 1 over u, this part is just going to go to a big fat 0, and negative 5 times 0 is a big fat 0. So this limit right here is just going to go to 0. And likewise, because this form right here is similar to this form right here, this is also going to go to 0. So this limit goes to 0. All right, so now that we have that established, right, we move to the next problem. The next problem we're going to solve is the limit as x approaches 0 of 3 cosine of x squared minus 3 over 9x squared. Be careful of the fact that the x squared is inside the cosine. So cosine of x squared is not the same as cosine squared x. We will see that case like later on. But to solve this limit, what do? We have to realize the special limit definition, right? Limit as x approaches 0 of cosine of x minus 1 over x equals 0, right? We've seen that limit definition, so I'm just having it written down for reference. Okay, how are we going to get that? Well, we have to somehow make a cosine of x minus 1 form appear, right? What we can do is we can probably pull out this 3 to make this expression a little bit simpler, right? So this is equivalent to the limit as x approaches 0, 3 cosine of x squared minus 1 over 9x squared. This is equal to the limit as x approaches 0 of cosine of x squared minus 1 over 3x squared. And now we see we have a cosine of x squared minus 1 over an x squared. So this x squared is matching up with this x squared. So we can make a substitution, right? So I'm going to do that in blue. So let u equal to x squared. So what this means is because x is approaching 0, u is going to approach 0. So this is going to be equivalent to the limit as u approaches 0 of cosine of u minus 1 over 3u. And we can pull out this 1/3 right here, right? So this is going to be equal to 1/3 limit u approaches 0, cosine of u minus 1 over u. This term is going to go to a big fat 0, and it's multiplied by 1/3. So this is going to be equal to 0. So that's nice and dandy. So factoring and making use of the special limit definitions saves the day for this problem. All right, the next problem we're going to solve is the limit as x approaches 0 of 3 cosine squared x minus 3 over 5x squared. Now, be careful about this problem. We're not taking the cosine of x squared. So the x squared is not inside the cosine. We're actually squaring the cosine, right? So cosine of x squared doesn't equal cosine squared x. Okay, so how are we going to solve this? We're going to use a similar approach that we did in the previous problem, except there'll be a twist. Okay, so this is going to be the limit as x approaches 0 of 3 cosine squared x minus 1 over 5x squared. And then you're going to see here, what is cosine squared x minus 1? Well, if you remember from the unit circle video, we know that sine squared x plus cosine squared x equals 1. So we know that cosine squared x minus 1 is going to be negative sine squared x, right? So we know that sine squared x plus cosine squared x equals 1. So cosine squared x minus 1, you bring the 1 over and bring the sine squared x over. So this is going to be negative sine squared x. So this is going to be the limit as x approaches 0 of 3 times negative sine squared x over 5x squared. And then if we simplify things a little bit, we can pull out the 3 over 5 since it's a constant multiplier. We'll actually pull out the negative 2 since we don't want to worry about that. And now we will see here, we have the limit as x approaches 0 of the quantity sine x over x whole squared. And now we have a composition of functions, right? Because you're having the function sine x over x composed within a x squared function, right? So what we can do is we can kind of bring the limit inside, right? So this will equal to negative 3/5 times limit as x approaches 0 of sine x over x whole squared. And what do we know about the inside limit? Well, this limit is clearly the special limit definition we went over in the previous two videos. So this guy is going to be 1. Now what is negative 3/5 times 1 squared? Well, that's negative 3/5, and that's the answer to this problem. All right, so hopefully you had a blast with this problem because, while this problem might look like, using this special limit here, the identity of sine squared x plus cosine squared x equaling 1 makes this problem actually translate to using the sine x over x special limit. So that was a cool twist. All right, the next problem we're going to solve is this one. The limit as x approaches 0 of sine squared x cosine of x over 1 minus cosine of x. So immediately at this problem, it's not obvious like what special limit we're going to use. But what we can do is take advantage of our trig identities. Namely, what is sine squared x, right? Well, we know that this whole problem is expressed in terms of cosines. So maybe it might be good to our benefit to express the sine squared x in terms of cosines. And we can actually, because we know sine squared x plus cosine squared x equals 1. So sine squared x is simply going to be 1 minus cosine squared x, because we can just bring this cosine squared x over and isolate the sine squared term. So this limit is equivalent to the limit as x approaches 0 of 1 minus cosine squared x cosine x over 1 minus cosine x. And now because you have a 1 minus cosine squared x term, we can actually do some factoring. This is going to be equivalent to the limit as x approaches 0 of 1 minus cosine x, 1 plus cosine x, cosine of x, over 1 minus cosine of x. And it's nice that we did this factoring right here using the difference of squares pattern, because these terms here cancel. And now all we can do is plug 0 in, right? So what is cosine of 0? It's just 1 by the unit circle. So this is going to be equal to 1 plus 1 multiplied by 1. So this limit becomes 2. All right. Hopefully you kind of are seeing the catch with these trig limit problems. Sometimes it might be good to use variable substitution to convert the trig limit into a form that you know how to evaluate the limit of, or it might be best to do some factoring to make the expression simpler and make it so that a substitution could work. And in this case, factoring saved the day for this, just like we seen in the previous limit practice video. Okay, next problem we're going to solve is the limit as x approaches 0 of cosine of 2x minus 1 over 2x squared. Now, this form clearly if you look at this problem, right, we have a cosine of x minus 1 over something with the 2x squared, right? Well, if you look at our special limit, right, we know this fact, right? The limit is x approaches 0 of cosine of x minus 1 over x equals 0, right? We have that fact as established right here, right? Okay, so now that we know this fact, right, how do we convert this problem into exposing this special limit? And the answer is you can kind of work with the denominator a little bit, right? What if I wrote the problem like this? Is it more apparent now how we evaluate the limit? And the answer should be yes, it should be a lot more apparent how this limit is evaluated. Well, actually, I got you a little bit, because we don't want to do that. That's going to not really solve our problem. So one thing you might see is for this problem, right? You might think to use a special limit. But if we were to go this path, right, and kind of separate out the 2x squared into 2x multiplied by x, then if you do the product property, right, you'll get a 1 over x, right, exposed. And then from there, right, what do you do, right? The limit's undefined. But that is a sign for us to try a different technique. And what is the technique? Well, think about how we've derived this special limit originally. We've derived the special limit originally by using the conjugate. And I think that's the technique we should try for this. So we'll take the limit as x approaches 0 of cosine of 2x minus 1 over 2x squared multiplied by cosine of 2x plus 1 over cosine of 2x plus 1. This is going to be equal to the limit as x approaches 0 of cosine squared 2x minus 1 over 2x squared cosine of 2x plus 1. All right, so we know cosine of squared of 2x minus 1 is negative sine squared 2x by the sine squared x plus cosine squared x equals 1 trig identity from the unit circle video. So we're going to just take advantage of that. So this is equivalent to the limit as x approaches 0. So this becomes the limit as x approaches 0 of negative sine squared of 2x divided by 2x squared multiplied by cosine of 2x plus 1. And now you see here, right, we have like a sine squared 2x over x squared. So what we can do is we can kind of separate out the terms a little bit, right? So we have the limit as x approaches 0 of 1 over 2 multiplied by cosine of 2x plus 1 multiplied by negative sine squared 2x over x squared. And this is equivalent to the limit as x approaches 0 of 1 over 2 times cosine of 2x plus 1 multiplied by negative of sine of 2x over x whole squared, right? This form is equivalent to this form, right? And now what we've done here is we've exposed a sine of something over x form, and we can apply our special limit. Now, we'll have to go through the product rule to separate out the individual terms in this product. So we're going to do that right now. This will be equivalent to the limit as x approaches 0 of 1 over 2 times cosine of 2x plus 1. I'll move this negative right here to make our life easier. So if we plug 0 in for this limit, right, cosine of 0 is just 1. So 1 over 2 times 2, this is going to be negative 1/4, right, because of this negative here. And then the limit is x approaches 0 of sine of 2x over x squared. Bring the limit inside, right? So bring the limit in here. So what's the limit as x approaches 0 of sine of 2x over x? So this is going to be limit as x approaches 0 of sine of 2x over x whole squared. We know from the previous video, a form like this, the answer here is going to be 2. So 2 squared is going to be 4. So this is equal to negative 1/4 times 2 squared, which equals negative 1. So that's a nice special limit. It forces us to use some factoring combined with using another special limit, which is the sine x over x form. So that's pretty convenient. And that wraps up part 2 of the special limit practice video. Tune in next time for the part 3 of this video, and don't forget to leave any comments if you have any questions or concerns, and I hope to see you in the next video.